Hello and welcome friends, my name is Aditya Pawar and let's start our journey to the universe. So in this lectures, I am going to talk about another episode of Space-time Singularities. You all will question that why I am making this episode. I am making this episode again because of some errors which were caused in my previous episode. Hence, this is another episode, a little bit verified and little bit extra version of that previous episode. So let's start our journey to the universe. So now we are going to discuss about space-time singularities. So what are space-time singularities? So space-time singularities are a region of space-time where the curvature of any object which is put into the curved space-time gets so elongated that it creates a curvature which is a shuttlecock image in an Euclidean space-time. So it creates like this image of visualization because of the we know that from the Newton's laws of motion that any object which has mass also has gravity. So mass is proportional to gravity according to Newton. So as we all know that our space is not like what Einstein predicted and thought. Einstein thought, because of his cosmological constant which is denoted by lambda, he thought that our universe is flat and not initially curved or is not affected. In this flat space time, our stars, galaxies and everything come. But as we have evolved from so much 100 years, that we now know that our real space-time, which is the 3D space-time, Euclidean space-time you call it, which is that is curved. So hence this body of mass creates an curvature which is proportional to the mass and creates its own gravity. So now this has a fun fact. That fun fact is that as this mass creates its own gravity, because of the length of it, the outer energy and outer pressure comes into it, which creates this much energy. And then as this energy reaches, gravity plays its own and strange laws, which strange motion, which is that as this energy comes in, gravity recreates itself. It means that it decouples itself, and like that, as much as energy is coming through it, gravity goes down and goes down until a single point, singular space-time, which we call space-time singularity, a gravitational singularity or a black hole singularity. So why do we take this black hole singularity? As the black hole forms, it has a protective shield which we call an event horizon. This protective shield has an inner boundary which is secured by its protective outer shield. So that inner boundary, which is infinitesimally small, is called the singularity, and it is very dense. The gravity beyond the event horizon gets so immense and so powerful that nothing, not even light, can escape from it, which we have recalled from so many years. So this protective shield covers the inner smaller shield, which is singularity, and which is infinitesimally dense, infinitesimally round, and infinitesimally with it has the densest object in the universe, all of space-time. So as this boundary of region is being created, our current laws of physics are all destroyed. Why? Because at the singularity, as we have understood it from the solutions of Karl Schwarzschild, which says that I have already said that Rs is equal to 2m divided by c squared. So that 2m is the mass of the star, and the g, which is the capital G, Newton's gravitational constant, which is on Earth 6.967 multiplied by 10 to the minus power of 11 kilograms. As this mass reaches up to that singular point, it has been created a initial singularity. As we calculate the physics of this singularity, so we take the radius is equal to 0 and time is equal to 0. But as we calculate according to the Schwarzschild solution, which is Rs, so we take Rs and divide it by 0, which is almost invalid in both of physics, maths and everything. You can't divide anything with 0, or can't take anything from 0. Hence our current laws of physics are breaking down in these singularities. But as we have discovered and we have evolved, like our human species, our technological species are also evolving, and we are also doing a further leap into the technology as we evolved in our intelligence. So one time will like that, when our technology exceeds so much that we know all about black holes, even its singularities, which are not understood till now, from the 1950s when John Archibald Wheeler taught it. So now we have discussed the main introduction of space-time singularities. Now these singularities are also said to be in Big Bang. So as we all have known, and also see my previous episode, that also see my playlists on the Big Bang, which are that the Big Bang was a fist of creation which created our entire universe, our entire humanity, and the whole earth which we live in. The whole universe was created from a single dense point called a singularity. This was the idea of Stephen William Hawking in 1970s. As his colleague Roger Penrose, which is also a theoretical physicist and mathematician, said that according to him, Big Bang wasn't being created at all. Big Bang was already there. That means he said it according to his theory CCC, which is cosmological cyclic universe. That said that our universe is one of our pre-indecent universes which lived there and died there. As these generations, like our own generation, like we live in the 0.7 civilization, because of all the evidences happened in the past, we are here. Hence, like that, all the evidences which happen in space-time, that's why they are here. So Roger Penrose thought that this was our main creation, because because something can't come from nothing, as there is no energy. There was no energy before the Big Bang. How can you prove that a Big Bang suddenly came into existence and exploded? That can't be really true. Hence Roger Penrose said the cyclic universe cosmology, that we have continuous universes forming and ceasing. So this was why the Big Bang singularity was initiated, which is a strong gravitational singularity which expanded the whole universe. And this would be my next video's topic. So stay tuned till the whole lecture. Now we have understood the black hole singularity and the Big Bang singularity. Now we have to understand the visualization of singularity. So I am going to represent you a diagram, and its other diagram would be on my left side of the image you can see. So as I have said in my previous video, that imagine a cylindrical three-dimensional cylindrical diagram in Euclidean space-time, because we can understood all properties in 3D space-time. When we go to Minkowski's space-time, which is in 4-dimensional, things start to become a little strange. When we calculate and do the calculations, we have to be a little more precise with mathematical calculations and physical, observational and theoretical calculations, because it goes with 4-dimensional or x, y, z axis and the one time axis. So in this 3-dimensional, there is a cylindrical passage which is the event horizon, the protective outer shield of the black hole, and the center line represents a singularity. This singularity is likely to be in all of the black holes, the center of the black hole, always in the center of the black hole, because singularities can be without black holes, but it is not proved and it violates because we have a theory called the cosmic censorship hypothesis or cosmic censorship conjecture, which tells not that naked singularities can't exist and are unreal. Hence, these singularities need a protective shield, which we call event horizon. You all will discuss a question that why doesn't naked singularities exist? So I have a proof for that. Because if we create a naked singularity, imagine we create a naked singularity out of the black holes, inside out. We create a naked singularity, and then our whole entire theory of general relativity, which we understand to use in astronomical macroscopic objects, gets violated at that point when we create a naked singularity. Hence, all of our physics, which we have understood from back in 1600s till now, is so many years has been destroyed that when we create this naked singularity. Hence, all physics and mathematics around the black holes gets destroyed, and all of cosmology gets destroyed. To keep this, we need to not consider the naked singularities. Now this visualization, now understand that we are sending some light rays to the black hole. So the event horizon, first of all, as the light goes towards it, if the black hole is uncharged and is has zero angular momentum, we call it a Schwarzschild black hole, which is a stationary object. So as this light goes towards it, light will go directly passing through the event horizon and into the singularity. But in the case of a rotating and charged black hole, like the Kerr black hole and Kerr-Newman black hole, as these black holes are rotating continuously, these black holes, when the light is going towards it, these black holes curve the trajectory of light and makes it go around the black hole's ergosphere, so called safe zone. This black hole, rotating black hole, which has, you can take any angular momentum of it, and then this so much speed of light also gets curved around it. So imagine that in that speed of light, or some object or rocket is sent at the speed of light, which is hypothetical only for thought experiments. If a person is standing there and then there is a curved black hole which he is going to observe, as he goes towards it, he will only rotate around the black hole if he escapes a safe distance around the black hole. If he did not and lose its efficiency to stable or maintain the safe distance from the black hole, the distance also depends on the size, mass and weight of the black hole. As this distance get a little bit of insecure or irrational, he will directly go into the black hole and would not observe anything. As far as he is obtaining a safe distance from the black hole, from the event horizon of the black hole, he would be in a process called frame tracking, as I have already said. Now I will give only a brief overview of it. That this observer, which is in the rocket ship, is moving towards the black hole and getting curved. The trajectory of his is getting curved, so he wouldn't at all discover and see what will he what is outside the black hole, because as he also does that, the black hole is continuously rotating and he is rotating with the reference frame of the black hole. Hence both of them, the black hole and the observer, wouldn't be able to do that because they are continuously rotating. The observer will also continuously rotate in the safe region of the black hole, because if you need to observe anything and calculate anything, that how much speed does it take and what is the behavior of anything, you need to stay at rest. You need to stay at rest or stationary. But in this black hole, as this is a rotating black hole, you will also rotate around it. Hence you could not do anything, you could not calculate what is the speed of the black hole, because you are also in the frame tracking process. Now as this light goes through a stationary black hole, the Schwarzschild black hole, it directly goes in. As it goes through a curve metric, it curves through the black hole. Now there are created some light cones which we represent in Minkowski space-time. So light cones you can represent in like 6 dimensions, because we have our normal 3 dimensions and plus 3 dimensions extra, which create it like a funnel shape and continuously like this funnel shape like this, and then you have the over boundaries of the black hole. So you can call it as a light cone. This light cone, which are being created from the light going inward, these light cones, some of it go inward the black hole. So light cones are in itself a topic, not only a certain thing. It itself is a whole branch of topics. So light cone are imagine that this point, and you have 2 cones over and under it. This point is the present point where the formation or the light cones are getting started. As this point, the past, if you ask the past world line or timeline of the light cones, they will say that they are also continuously moving, and at the present time it is also continuously moving. But which some light cones which have gone into the event horizon would say that they were in the past, which is I minus, they were going into the black hole. In the they will say that in my present they were also going, and in the future they will say that we directly go into the black hole. But some of them are very lucky that they escapes the black hole. So they will say that my past I was going into the black hole, my present I was going into the black hole, and my future saved me from doing so, and I escaped from the black hole. You can also escape from the black hole, but if you have a speed which is greater than the speed of light. As you do this, the Einstein's mass equivalence principle, which says that nothing is faster than the speed of light, c squared, nothing is faster than the speed of light in our entire universe. Hence, if somebody of you would go faster than the speed of light, you could escape, but it is hypothetical. First of all, we couldn't reach the speed of light, which is 186,000 miles per second or 3 million kilometers per second. As from many researchers, they have calculated, so light doesn't have a certain thing. From my perspective, I will take 186,000 miles per second. So our humanity hasn't reached the speed of light, but is a little low than the speed of light. So we can't, first of all, our humanity can't reach the speed of light, and then this escape velocity theory says that you have to travel more faster than the speed of light. So it totally destroys our current understanding of physics. Now this was the visualization of the black hole and how the singularities are being created and how the singularities act on the black hole. Now coming to the naked singularities, as some of these black holes which are rotating, the angular mass of the momentum of the black hole continuously rotates in the Kerr metric. It continuously rotates, and the rotation is accelerating at the speed of rotation is accelerating. As this does, at a final point the event horizon completely destroys, and the naked singularity, which is the singularity in the inner surface, I call it as inner surface or trapped surface, which Roger Penrose called in his twistor theory. This inner surface, trapped surface or inner surface, is directly, without any shield, being called in the whole universe and seen by the whole universe, which would first of all have not been detected, but only not been detected also by theoretical mathematical proofs. Observational proofs are a little bit higher, and we need that equipment which and that theories, that type of intelligence to tell what a naked singularity really is and how to find a naked singularity. Till now we haven't discovered naked singularities, so it is still a mystery from the 1950s till now. So this was about naked singularities, visualizations, and my most earlier ones, which are black hole singularities and the Big Bang singularities. This was a little bit of abstract of all that. Now I am coming to that the structure of black holes. When you take the diagram in Euclidean space-time, as I have already discussed, now we will take Minkowski space-time. As we go into the Minkowski space-time, imagine that same light cone, and now this light cone's diagram now converted into the black hole is called Kruskal-sezerkes diagram or coordinates. So this Kruskal-sezerkes coordinates, or you can normally imagine as Penrose diagram. This Kruskal-sezerkes coordinates says that you have a past time-like curve, which because it is closed, you can see that image, because the time-like curve is being closed, hence it is a closed, but the boundary of it is open. That close goes into the present time-like curve, which is neither closed nor open, because we can't predict it. It is a singular point. And as we go to the future of this Kruskal-sezerkes coordinate, it again gets closed, but the boundary of reaching upwards in time is open. So this was the whole visualization of Kruskal-sezerkes diagram. You can imagine that from the formation of star. So as this star or mass, now this topic is in gravitational collapse. As this some matter is going throughout life, take a star. As this star is going throughout life, at its very extreme point, when it is at the death stage, the inner pressure created by the core directly gets stopped, because the center of the core creates a element called iron, which is the heaviest element ever a star has produced. Hence the iron core has been created. Hence it is a metallic core, and continuously not starts expanding. Hence the outer pressure, which has no inner pressure to counterbalance it, the outer pressure takes towards the whole mass of the star and collapses to two certain radiuses. The first one is the Chandrasekhar limit. The Chandrasekhar limit says that At a certain period, the whole star's mass would turn to be a white dwarf. Hence, it would create into another star which is 10 times or 100 times smaller than the original stars, but the mass has been increased than the original mass of the star. So at the Chandrasekhar limit, when it reaches the Chandrasekhar limit, the white dwarf star will continue to stay in its life, but in some consequences, the gravitational force continuously goes down and down, because I have said that energy is proportional to gravity. So as much energy you do to it, as much gravity it would do. Hence the pressure decreases into a small area which we call the second one, Schwarzschild radius. As the black hole reaches the Schwarzschild radius, the whole region continuously goes in and forms singularity and then bursts out from this singularity like this, as this matter goes in and then bursts out and forming and creating a new black hole. So the age of the black hole, which has been approximated to 10 to the power of 100 years. At these black holes have two main properties, which is information paradox and Hawking radiation. Information paradox says that anything which is being sucked into the black hole. So you can take like anything, like an object. Imagine a ball. So this ball, we can state its color, its size, its weight, its dimensions, and etc. But the main thing of it is that it is made up of atoms, and it is made up of the fundamental building blocks of nature and the universe and physics. Hence, these tiny particles and tiny pieces of information goes into the black hole, are stored for some time at the event horizon of the black hole. So at the event horizon, anything which have been, when the black hole was started, anything which was directly gone into it, the event horizon keeps it for some time. As the black hole reaches millions, billions, and trillions of years, this information starts to fade off, but little bit by little bit. So like 0.1% of 1 nanometer of it only gets out of the black hole, or radiates out of the black hole because of the black body radiation curve. You can see that black body radiation curve for Hawking radiation. As it reaches its final end, which is 10 to the power of 100 years, the black hole is the size of again a Schwarzschild radius, and at last, when it has covered the whole mass, for some seconds it lives and then directly collapses into nothing, and that the supernova is being created because of all the energy created. But as this very 5 seconds or 10 seconds you take, the black hole also emits gamma rays or radiations, and its angular momentum increases. As this angular momentum increases, like the pulsars which have 1000 kilometers per second angular momentum, this black holes also have an angular momentum which also increases, which is way more greater than the pulsars. So at the final stage, as it has passed its 10 to the power of 100 years, the black hole eventually fades out and dies. So this was the whole lecture of our series. So how do you like this advance a little bit way more lecture? How do you like it? Tell me in the comments below. How do you like, and can you find the differences between the previous episode and now episode? Tell me in the comment section down below. Like, share, subscribe if you want more videos like this. Share to your friends to get more knowledge to them, and make our humanity a more advanced civilization than now. Hence, like, share, subscribe, and thank you. I will see you in my next video. Peace.